Hi there, I am Ümit Alkuş. In this video, we will solve one problem in Chapter 5. Two blocks of masses M1 5 kg and M2 3 kg are in contact on a frictionless table. They are pushed by a force F which causes a varying velocity v equals 3 times t I hat meters per second. The angle between force F and the horizontal direction is theta equal to 30 degrees. A. Draw the free body diagrams for each block. For mass M1, first of all, we represent mass M1 by a big dot. Now we can draw the forces on the block. The first force is the gravitational force due to the gravity of Earth. And due to the surface, the normal force on the block is also the external force F on the block is, which has the x and y components like this. Finally, the reaction force applied by mass M1 on mass M2 denoted by F21 is drawn like this. Additionally, the acceleration is, if we notice, it is not drawn on the mass and we use different form of vector. Makes the free body diagram for block 2 is where F12 is the force applied by mass M1 on mass M2. Okay, these are the free body diagrams for each block. In part B, determine the magnitude of force F. In order to solve this part, it is convenient to draw the free body diagram for the whole system. Since acceleration is the first time derivative of velocity, we have 3 I hat meters per second squared. The net force in the y-axis is 0. And the net force in the x-axis is F times cosine theta. From the Newton's second law, we have then we get an expression for F as, with the numerical values, we obtain 27.713 newtons. And in 3 significant figures, it is approximately 27.7 newtons. In part C, find the magnitude of the normal force on the larger block. From the free body diagram of block 1, we have for the vertical direction F net y equals 0. This means that N1 minus F times sine theta minus N1 times G equals 0. So that N1 becomes, with the numerical values, we obtain approximately 62.9 newtons. In part D, what is the magnitude of the force between the two blocks? From the free body diagram of block 1, we have for the horizontal direction as, therefore we obtain F21 as F times cosine theta minus M1 times A. If we put the corresponding numerical values into this equation, we get 9 newtons. Similarly, for block 2, we have F12 equals M2 times A. With the numerical values, it is 9 newtons. Note that F12 equals F21, as stated by the Newton's third law. Okay, this result brings us to the end of the discussion of this problem. Thank you for your attention. See you in the next video.